Okay, welcome back. So this is your review 6 for lessons 26 and 27, ratios, rates, and proportions. I remind you that we will do this without a calculator. There are 16 questions, and I remind you that we want to think of this as a rehearsal for when you take a test, if you're in my live class, or if you're doing the self-assessment on iTunes, you're looking to get 80% of those questions correct or more. So just view this as a rehearsal and kind of as if you're doing a test with me. So let's dive in. Number 1, write the rate as a unit rate. Well, we're going to see a lot of word problems in this rehearsal and a lot of keywords, and we have to be able to read very carefully. So keyword unit rate. When I see the keywords unit rate, I know it means per one. Unit means per one. So I know I'm trying to write a fraction where 1 must be in the denominator. So I'm just going to write that 1 must be in the denominator. That's kind of the key thing with the unit rate. All right, so let's grab what we have here, which is 20,000 good assembly line products to 20 defective products. Well, all it says is write as a unit rate, okay? So I'm just going to write 20,000, I'm just going to write good, right? Good products to 20 bad or defective products, okay? Now, that's fine, but it's not reduced. So clearly 20 goes into itself once, and 20 goes into 20,000 1,000 times. So we reduce that. Now we're lucky because we got 1 in the denominator, which is the goal, and now we've got 1,000 good products to 1 bad product, which is the final answer. 1,000 good products to 1 defective product. So the main thing is when you I'm going to write this here, when you get a unit rate, you're seeking 1 in the denominator. Okay, let's head on to number 2. A large order of French fries has 360 calories. Wouldn't it be nice if it was 0 calories? Love McDonald's fries, side note, but a large order of fries has 360 calories. Of this total, 140 calories are from fat. Find the ratio, keyword ratio, of calories from fat to calories in your large order of fries. When they say it like this, you know, A to B, you have to write the ratio in that order. So calories from fat will become our numerator, and the calories in the large order of fries will become our denominator. That's the main thing. You just kind of have to map out to yourself. All right. So calories from fat will become our numerator, and total calories will become our denominator. All right. Now, the units, I mean, they're still calories. It's calories to calories. So the units are going to cancel out. But we have to reduce the 140 over 360, so we can cancel the zeros, you know, and then we're left with 14 out of 36, but you might be thinking 2 goes into this 7 times, 2 goes into this 18 times. So even if you have to note there, divide by 2, and voila, 7 out of 18. That's our ratio. So ratio of calories from fat to total calories, you have to do it in this order. All right, let's try the next. Again, with the ratio, you have to follow the order of the language. So find the ratio of the longest side to the perimeter. Okay, well, let's just start there. Longest side. 3, 4, 5. Aha. 5 is the longest side, so 5 feet. Ratio really just means fraction, right? So we can set this up as a fraction. Perimeter means add up all the sides. So 5 plus 4 plus 3. I'm just going to make a note here. Well, that's 12. And the units is also in feet. So feet cancels with feet, and you're left with 5/12. So the big thing is the reading. So when I see the word ratio, I know I have to make a fraction, and then longest side, that's going to go in the numerator, and perimeter, that's going to go in the denominator. Okay, let's head to the next one. This says solve for the unknown. Well, again, I'm assuming you've been through all my guided notes and you know how to solve a proportion. I'm just going to write this in my own handwriting. So n over 0.6 equals 0.01 over 10. By now we know an easy way to solve this is simply to cross multiply if we're solving for n. So 10 times n is 10n. You set the cross products equal to each other. So here's cross product, here's a cross product, and you set them equal. So whatever 0.01 times 0.6 is. Now, since we're not, so now we have 10n equals, and since we're not using a calculator, you might want to go off on the margin or something, let's say over here, and think about what 0.01 times 0.6 is. Remember, you ignore the decimals and count them up at the end. 1, 2, 3. So that's to be 3 behind the decimal, so 0.006. Keep going. To solve for n, we're going to divide both sides by 10. So we'll have n equals whatever 0.006 divided by 10 is. Now, you know dividing by 10 is basically going to slide the decimal to the right one. I'm sorry, I meant to say slide the decimal to the left one. So division by 10 will slide the decimal to the left one. So 0.0006 would be your final answer. If you don't have that memorized, you might want to physically set up that division. So like 10 going into 0.006. And then you'll see why it happens. 10 doesn't go into 0, 10 doesn't go into 0, 10 doesn't go into 6. Aha, but then you put a trailing 0, 10 goes into 60 6 times. So that's why you end up 0.0006. Okay? Some people just memorize that if I'm dividing by 10, I'm going to move the decimal to the left one. But okay, so there we found our answer, and obviously we have the answer snipped in here. Okay? Let's head to the next one. This one, we have a 40-foot tree casting a 12-foot shadow. Sometimes I just kind of draw it. It's a terrible tree. But, so we have, and it's not drawn to scale either. So we have a 40-foot tree casting a 12-foot shadow. Find the length of the shadow cast by a 23-foot tree. Okay, so now you've got a 23-foot tree, and you don't know the length of its shadow. The main thing is that we are dealing with sort of like a similar triangle situation here, that the sides are proportional. That 40 is to 23. Let's just go ahead and set that up. That tree is to tree as shadow is to shadow. You can kind of say it like that. So 40 is to 23 as 12 is to whatever you don't know, we'll call that x. Okay? And now we're just going to go ahead and cross multiply and solve. So once you set up that proportion, and as long as you're consistent, like tree is to tree as shadow is to shadow, you should be okay. Now we arrive at 40x equals whatever 12 times 23 is. And since I'm not, using a calculator, I'll just kind of go off on the margin and figure out what that is. Okay, so that's going to bring me to what, 276? And then we're going to divide both sides by 40 to solve for x. And so x is approximately something, whatever 276 divided by 40 is. And again, all of that sort of mathematical work I'll just do off on the side. So 40 into 276. Oh, it's not going to go perfectly, but 40 into 276, perhaps maybe about 6 times, because 6 times 4 is 24. Okay, and then we draw the line and subtract. Bring down a trailing 0 that's after the decimal, of course. Now we start doing decimal division. because 276 really means 276.0. All right. And then 40 into 360, oh, it is going to terminate. The decimal is going to terminate. So that'll be 9. And voila, we are arriving at 6 points. So it's not approximately, it's exactly. Change that to an equal sign. So 6.9. So now we see where the answer came from. The shadow is 6.9 feet. Okay. All right, let's head to the next one. Write the ratio means fraction, as a ratio of whole numbers using fractional notation in simplest form. Okay, so 17 hours to 34 hours. Okay, 17 hours to 34 hours. Is it as simple as that? Yes, but the units cancel, and then so happens 17 out of 34 reduces, right? 17 goes into itself once, and 17 goes into 34 twice, so we are arriving at 1/2. So note to self, make sure you reduce. Okay, cruising right along. Write the ratio as a ratio of whole numbers using fractional notation and simplest form. Okay, well, the thing is, 9 1/5 to 2 3/10, that's fine, dandy, but it's not whole numbers. Those are mixed numbers. So how are you going to like clean it up? Well, so we change to improper, and take it from there. Hours cancels with hours, so the units cancel. So if I change this to improper fraction, I have 46 over 5. I'm assuming you're good at that by now. 10 times 2 is 20, plus 3, so 23 over 10. Then you have this sort of complex fraction where you have a fraction on top of another fraction, which really means a fraction divided by another fraction. So we could rewrite this as 46 fifths divided by 23 tenths really means multiply by reciprocal, so multiply by 10 23rds. You arrive here and look for some cross cancellation. So 5 goes into itself once, 5 goes into 10 twice, 23 goes into itself once, and 23 goes into 46 twice, 2 times. And guess what? 2 times 2 is 4, and 1 times 1 is 1, and voila, 4 over 1. So if cross cancellation still messes with you, the only way around it is to travel straight across and reduce at the end. Like 46 times 10 would have been 460, you know, and 5 times 23 would have been another large number, and you would have to reduce at the end. I prefer to cross cancel. So cross cancel if you like, to help you clean that up. Okay, now for the given proportion, number 8, for the given proportion, find the unknown number. I feel like we can never have enough practice with solving these proportions and using the fact that you set the cross products equal to each other. So again, I'm just going to highlight that. Some people say, "Ooh, is this where we cross multiply?" Well, yeah, but you got to remember to set the cross products equal to each other to solve. So 7 times 6 is 42, but set that equal to 15 times n. And then if you want to solve for n, you obviously have to divide by 15. And whatever 42 divided by 15 is, now if I'm not using a calculator, I'm going to write 42 as 42.0 and perform that division. 15 into 42 goes about twice. And 15 into 120, let's say about, and line up the decimal, let's say about 8 times. And that works out nicely as a terminating decimal, 2.8. Okay, let's head to the next one. Solve the proportion for the given variable. And forgive if it seems like I'm going fast, it's because this is intended to be like we're doing a test together and that you've already taken all the notes and seen the guided notes on iTunes. So we're supposed to go through this with ease. All right, again, we're going to cross multiply to solve for this. X, 15 times x is 15x. We're going to set that equal to whatever 12 times 18 is. Now, if we don't know that off the top of our head, it's okay. We go off on the side and figure that out. That's a 216. Divide both sides by 15. And whatever 216 divided by 15 is. And again, you might have to go off on the side and figure out what that is in the margin somewhere. So 15 goes into 21 once. 15 then goes into 66 about 4 times. And then 15 goes into 60. We can line up the decimal there. 15 goes into 60 4 times. And voila, 14.4, which was the answer. Okay. Wow, we are cruising right along here. Okay, write the rate as a unit rate. Again, now we know unit rate means get 1 in the denominator, basically, of your fraction. The hummingbird moves its wings at a rate of 5640 wing beats a minute. And it says write this in wing beats per second. Now, we have to think a little bit. Just a little bit. It wants it per second. But we have it per minute. So just think about this. 5640 wing beats in 1 minute is question mark wing beats per second. But the thing is, I mean, let's just think about it logically. We need to get to seconds, so let's just replace 1 minute with seconds. Oh gee, there's 60 seconds in a minute. So we know that 1 minute is equivalent to 60 seconds. So that really means that you're doing 5,640 wing beats in 60 seconds, but aha, it didn't ask for per 60 second. It asked for per second. So it's like getting a unit rate. So how am I going to do that? I'm going to have to divide 60 into 5640. In other words, reduce this. If we luck out, it'll divide evenly. Of course, we have the answer there. 60 into 564 goes about 9 times. Draw the line and subtract. And 60 into 240 goes 4 times perfectly. And voila, 94. So long story short, 60 goes into itself once, and 60 goes into 5640 94 times. So you do end up with 94 wing beats per 1 second. So you do end up getting a unit rate and getting this solution. Okay, so the big thing is the units. Here I was given a minute, but I need to replace 1 minute with what it is, which is 60 seconds. Hope that helps. I know conversions can be tricky sometimes. A university law school accepts 7 out of 12 applicants. If they accept 651, how many applicants did they receive? So just think, I'm just going to write it like this. 7 accepted out of 12 total is to, set up a proportion, is to 651 accepted, A for accepted, out of how many did they receive? That's unknown. So really you just have to make sure you're setting up that proportion. So 7 is to 12 as 651 is to x. And then again we can cross multiply and solve. So we end up solving 7x equals whatever 651 times 12 is. And now I'll let you go off and think about that on your own. Should be 7812. Okay. Divide both sides by 7. And again, if we're not using a calculator, we have to figure out what 7812 divided by 7 is. We can just kind of do that off on the side. And that's where we're arriving at that 1116, which is the final answer for the number of applicants. Okay. Hope that helps. Let's head to the next one. We have here similar triangles. Keyword similar. That means the sides are proportional. That means that slanted piece is to slanted piece. It looks like a hypotenuse here. So hypotenuse is to hypotenuse as leg is to leg. So we want to set up that proportion. So, you know, like 30 is to 33 as 50 is to n. And make sure you're being consistent, like, for example, small triangle is to bigger triangle as smaller piece is to bigger piece. So just have to be really consistent in how you're constructing that proportion. And again, we cross multiply and solve. So 30n equals 33 times 50. What I do is I take 33 times 5 and then just tack on the 0. And then right at the end, to solve for n, we're going to divide both sides by 30. Zeros cancel, so whatever 165 divided by 3 is, which is 55. And voila, we got the missing piece. All right, and now number 13. And remember, I believe there's only 16 problems. So this one, again, we're just practicing cross multiplication. Don't be afraid of the fractions. So 3/7 times n is just 3/7 n. And 63 times that fraction is whatever that is. So I would write it as 63 over 1 times 21 over 49. Okay? Now look for cross cancellation here. 7 goes into 49 7 times, and 7 goes into 63 9 times. Okay? So then you have 3/7 n equals, well, let's see, 9 times 21 is 189, and 1 times 7 is 7. So when you arrive here, you're just about ready to solve for n. You have to divide by 3/7. So I'm just going to write here divide by 3/7. But here I'm going to write divide by 3/7, because I know that division really means multiply by the reciprocal. And you get that nice cross cancellation, and you get 189 over 3, but that obviously reduces to 63. And voila, we got the answer. Okay. So even though there's fractions in the proportion, don't let that scare you. Still solve it the way you always do. Okay, this next one I had to put in here is a very common problem when you're dealing with unit rates, is the better buy problem. So what's a better buy when you're shopping? Let's $1.59 for 8 ounces or 96 cents for 6 ounces. So some people automatically assume, you know, that the more ounces is better. Not necessarily. You have to look at the unit rates. So, all right. Well, let's divide the 6 ounces into the 96 cents to get a unit rate. 6 goes into 9, 1. And 6 into 36. So there we're looking at about, that unit rate is about 16 cents. So I'm just going to write here 16 cents for 1 ounce. Now let's divide the 8 into the $1.59 to see what that unit rate would be. Well, whichever one's cheaper, you know, the better unit rate is the better buy, long story short. So 8 into 15 just once, and 8 into 79 about 9, And right there, right there you're getting more expensive. An 8 into 70, about 8. So right there, no matter what, this unit rate is higher. So this is the better buy. Because, here we're close to 20 cents per ounce. And here we're only 16 cents per ounce. So this one's better. So long story short, the lower unit rate, the cheaper unit rate, is the better buy. Okay, let's try number 15. Determine if it's a true proportion or not. Well, now we know the fastest way to deal with that is just to see whether the cross products are equal. Because they better be if it's a true proportion, right? So 0.6 times 0.1 is a 0.06. So note to self, check cross products. They must be equal. Um, 0.8 times 0.8 though, so I'm just going to write, I'm not going to write a verse, I'm going to write verses. 0.8 times 0.8 is 0.64. Well, they are definitely not equal. Okay, so it's a false proportion. So not equal, false proportion. All right, and last but not least, number 16, 4 out of 7 people choose vanilla as their favorite ice cream. I'm just going to write here for vanilla. 4 choose vanilla as their favorite ice cream, 4 out of 7. If 168 people attend, so I'm going to say 4 out of 7 total. If 168 people attend an ice cream social, how many would you expect choose vanilla? So that's X, and 168 is the total. So again, setting up that nice proportion and cross multiply and solve. So we see a lot of that in this segment. So 7x equals whatever 168 times 4 is. And we can do that off on the side. So it's 672. And then divide both sides by 7 to solve for x. And so we can take 7 into 672. And it may or may not go evenly, we'll see. Yep, 7 into 42 goes 6, so it did go evenly, so 96. So we're expecting about 96 to say they would like vanilla. All right, so that was our last one for that review. That means you're ready to do your self-assessment. I know you'll do fine, and I hope that helped. And feel free to go back over in slow-mo any problems that you were really stumped on. Good luck out there.